It does not work. This project cannot work. There is no way for this project to work now. You guys loved my computer project, so we are running it back. Last time, the system was able to add 2 sets of 2-bit numbers. This time, we're going bigger and better. This time, you can not just add, but also subtract numbers. In this generation, 4 bits. Total combinations of computations, 512. That's right. This generation of Unch's Computer Plus is 36 times more capable than the last one. It is bigger. It is better. It also seems like it's going to be harder, but we will see that. We are going to be creating the successor to one of my greatest videos and one of my favorite projects. Welcome to Unch's Computer Plus, the next generation. All right, step 1, planning. Similarly to last time, a simulation software was used to simulate the machine. Yeah, I settled with having 2 sets of 4-bit inputs, an operation button, which when toggled would be in subtraction mode and would subtract B from A. And then when that button or when that switch is not toggled, it would add the 2 numbers together. Finally, I added a last kind of calculate button that you put in your input and then you flip calculate, and then that'll enable all the LEDs to actually present the information. And so this design boiled down to 4 full adders that are all connected to each other, which did the addition for you. And instead of having logic for the adders and then having separate logic for the subtraction part, all I had to do was figure out a way to take the 2's complement of the second set, so input B, the 2's complement of that input when the operation switch is toggled, and then add that 2's complement version of B to A, which is equivalent to A minus B, right? And so by doing that, I was able to simplify the logic down to just having the base 4 adders and then having logic to take the 2's complement. And to do that, it wasn't too difficult. I had to essentially, I ended up using XORs with the B value and the operation switch. After messing around a bit, I was able to get the initial testing working. The design was, in its early stages, functional. The issue was, however, I didn't buy any XOR gates. I had a lot of NAND gates though. So what I did is I took the XOR gates and then I NANDed them. Now what that means is I took the base logic for an XOR gate and then I basically just negated it twice. And I was able to create essentially a model of an XOR gate only using NAND gates. I was able to get it to 4 NAND gates. And conveniently enough, the chips that I was using are 4 gates. Like they have 4 gates of 2 input NAND gates. And so a single one of these chips, when routed correctly, was able to produce the XOR. From there, I modeled the full adders, also implementing NAND gates. And I was able to get it down to these 2 sets of XORs that are made of NANDs, and then 2 ANDs and an OR, but that made the board really messy, and so I changed that to also NANDify it. So I NANDified the 2 ANDs and the OR into 3 NANDs, and That was like the logical equivalent of it. And so by doing that, again, I was able to just make the board a little neater, and essentially the entire logic for the system could be implemented with NAND gates. So that was the plan. That was the plan. I retested, reran the simulation, everything was working fine. So I began with the next step. Let's get started. Alright, so we've got the initial layout done in accordance to the plan. So we're going to start here with the first 4, which is Group A. Group A is our set of XOR gates. So we're going to set up each of those here, and yeah. It does not work. I was able to wire up one XOR gate. This breadboard sucks. I cannot put wires in it very easily, which is why it's taking me so long just to do one XOR. And even then, it's not an XOR. It's just always on. Currently, we've got both our inputs with power. The LED is on. That's not what an XOR should do. So currently, all I have is an LED that turns on, which is not at all what we want. I'm gonna have to purchase different breadboards. Now that we've got the new boards, hopefully these will be a lot easier to use. And do you see how that just went in? Do you see that? See how that just went in? Now look at this. Let me try and do that on this board. Look at this. I kid you not. Look at this. Look, you seen that? It is not going in. It's bending the wire. Just getting this done took way too long. But that's alright, because now we've got our new boards here. Got the new stuff, and we will try this again. Okay, I did just bend the thing trying to put this one in as well. Look how fucking weird this is. Look at this. Hi, future on chat. I didn't realize it at the time, but this was my foreshadowing. This was my warning sign that something isn't right. At the time, I didn't think much of it. I just thought it was cool, I guess. But it comes back. Just keep your eye out for it. What the fuck is going on? Okay, time for an update. All of these, like you see the red and the yellow, same with the yellow ones here, they're XOR gates. This chip and this one are both AND gates, which feed into this chip, which is the OR gate. And it's just really, it's kind of messy, and I don't like it. It looks kind of gross. And so what I'm thinking I might do is replace them with NAND ICs. So that should work in theory. I'm going to now pull all of this out and test that out. Yeah. Okay, the new wiring is now complete. On here, the part that's left to do, well, there's a few things left to do. I mean, currently we've got no power source, no input source. The power source for now is this. This is rather simple. This is just because I have a calculate button, so that once the user flips that, then the lights will appear. That is all handled on this board, which has no wires on it either. But this board will also have all the wires for the input. Now, the input are going to be taken from these things. 10 of these switches here, and so they, if I can see how that, it's like a switch, just like, it's kind of hard to do it with one hand. And so I'm gonna have 10 of those. Using the soldering machine, we'll get the soldering for all of these done, because a total of 10 inputs, so all of them will be soldered and then connected to the board, and then connected for now to this power supply at 3.3 volts, because there's a lot of chips now, and previously I was powering the old computer, which still works. It's good to go. I was powering all of this with a single coin battery. Don't know if this is gonna last very long, since all of these chips now take the same 3.3 volts. So I'll probably have to use a power supply like that for now. But we'll suss that out later. Now, I was able to test the individual XORs, but I haven't really tested the NAND gates used for this bottom part here. So that's the carry bits. That's in charge of the carry bits. I haven't tested, but hopefully it still works. All right, time to solder. Alright, let's see what these wires do. Soldering job was not great. Yeah, we'll make do. We will make do. What I'm going to do is I'm going to start designing a housing to keep all 10 of these, and see if I can fit that housing within this distance here. So then all the switches will be on the top here. This is that row of ands there. We'll test out some prints on the 3D printer, and we'll verify from there. Okay, the holder is looking pretty good. It's fitting the switch quite well, and so I've just put the nut on the top here, and so that's feeling really good. Plan is for this to kind of sit on top like so. You can kind of see how that's fitting, but yeah, so this is a good initial test. We've got the initial test for the soldering done as well. So the next step now is to repeat this 9 more times, test all of them to make sure that all the connections are good, and then move them to this, build a proper way to connect this piece onto the board, whether that be another piece of plastic, I'm not quite sure yet. But from there, we'll hook that to the rest of this, wire everything through, and then start testing to see if it actually works or not. Which I'm a little scared about. I'm a little scared that the initial testing is going to happen, not the initial testing, but testing the entire system is going to happen after all of this work, which is going to suck, but minutes later, I've got 4 of them wired up, and then this one's pinned, like that leg got loose. But I don't really like it. I know I'm not using the right wires, and these ones tend to snap, and I'm not great at soldering. I mean, I hope these connections last. One of the switches here was one that I had already soldered wires to, but they fell off. And so I think I'm gonna have to scrap these specific switches and go for another idea. And so what I've got in my head so far, using these type of buttons, I'll put them in a case where the user will be able to push down and then slide a slider to lock it so that it's pressed. In the previous design, the user had to just kind of hold down the buttons for the calculation to work. So I don't want to do that for this one, which is why the plan was to use switches, but it's too messy. I don't like it. So we're gonna go back to the buttons, but we're gonna have that extra of probably 3D print some mechanism so that the user can press it and then slide it to lock that selection in. So that is now the new plan. Okay, so I was able to find some buttons. I got 8 and then these 2 random ones. We're currently trying to figure out a way to do this, and it's not going to work on the first try, and I can guarantee that it's not going to work on the first try. But the plan is we'll have this piece of plastic that wraps around here, and there will be this rectangular hole which will have a piece of rectangular plastic with a bit sticking up that the user can press and then slide through this hole here. And now we're just going to go through, link all of these up, and then return them back up here because this is where the output will be. I'm gonna be real. I don't know what's going on anymore. I do not understand what is happening. The wires are not long enough to reach for where they need to be. So in some cases, I'm using 2 wires to bridge 1 connection. And I haven't even started testing this yet. I'm still trying to wire up all the inputs. And I don't know if this is gonna work. I am on my 5th adapter thingy for the buttons, and it's still not working. We're getting close. Currently, the issue is when I put the pins here, which push down on the buttons, the plastic tends to lift up. And so what happens is it kind of bends like this. And when this happens, the button is no longer pressed. So what I've done is I've designed kind of a bracket that'll attach here and here. And that should hopefully stop it from flexing up and making sure that the buttons work. Because the first 4 work, but then afterwards it doesn't work. So we'll put that bracket on and then see. It works. These pins slide through. Just keep the button pressed here. And these are all working. Ready to go. This is how to disengage the button. And so this is the final stretch. Hours and hours of work have been spent in designing and planning and routing and getting over this problem. And now this is it. The final wires will be wired up. The output will be somewhere. I don't really know at this point. Might put it on that board. I don't know, but this is it. This is it. Okay, from my understanding and initial testing, everything should now be wired up. I don't know if this is gonna work, but there's only really one way to find out. So I want to add this. Well, that's completely wrong. Notice how the lights are flickering? Yeah, it's back. Alright, it doesn't work. Time to fix it. I tried to fix it. You know, I first figured out that I had wired the pull down resistors wrong on the buttons, and I thought, that's it. That has to be the issue. So I broke apart the fix that I had. I rewired them. I tested all of the buttons with my multimeter. They were all stable. They were all working. I then found a couple wiring issues that had wired the wrong things in the wrong place, and so 2 of the LEDs just stayed on because they weren't wired correctly. And so I fixed that, and I thought, you know what, this is it. This had to be the issue. And then I turned it back on just to get the same noisy output, and I didn't really know what to do, and so I did a bit of research, and well, that's where I kind of figured it out. It does not work. This project cannot work. I should have researched that. I didn't, but I am pretty sure there is no way for this project to work now. Essentially, it seems like, from my understanding, that the 7.4HC chips, because their output current is so low, because I have so many wires going across everywhere, and they're all feeding, you know, into each other and whatever, all the wires are kind of picking up signals from other wires, and that's what's creating the noise. And there were so many problems on the way, that I had to fix kind of step by step. As much as I hate to do it, I'm gonna have to pause development on this project for now, because I don't have the materials to continue to make a functioning version of the project that I have in my head. You know, I just don't have it. But this isn't the end. No. Because we will be turning this into a series. This is part 1. We've had some issues. We've learned a lot of things. We're not done. We'll be coming back. Part 2 coming out. Who knows? This year, next year, who knows? But there will be a part 2. We will be fixing this issue. I don't know how, but for now, this is where we're at. A messy bundle of wires. We'll be back bigger and better, and it will work. What's right?